Hey everyone! In this video, we are going to be solving exact trig ratios from a known point. What are the trig ratios? Well, there are three of them, and I think you're going to be familiar with them. We have sine, we have cosine, and we have tangent, very commonly called sine, cos, and tan. And I hope that everyone remembers their pneumatic device, so, ka, and toa, because that's going to give us the equations for solving our trig ratios. So our three trig ratios are sine of theta equals the opposite over the hypotenuse. That's our first trig ratio. Cos of theta is equal to the adjacent over the hypotenuse. That's our second trig ratio. And the third one, tan of theta, is equal to the opposite side divided by the adjacent. And that is our third trig ratio. When we are done, we will not have solved for theta. What we will have done is solved for these three fractions. 1, 2, 3. A sine fraction, a cos fraction, and a tan fraction. And that's why they're called ratios. Ratios are fractions. But because they're exact, we will have to reduce these fractions as best we can, including the radicals. So if you haven't checked out my last video yet on how to simplify radicals, now might be a good time to scope that out because we will be simplifying radicals here. Let's get a point on our graph. We're going to put one at 6 and 4. 6, 4, and I'm just going to go ahead and draw a line here so that we can see what our terminal arm looks like. When we decide where to place theta, theta is always going to be the reference angle, which means the smallest angle we can make from our terminal arm to the x-axis, which is right here. We can go ahead and drop this down, and now we know two of our three sides. We know that this height is 4, we know that the distance along the bottom is 6, but we don't know this hypotenuse. We can get the hypotenuse. We can use Pythagorean Theorem. We can say that c squared equals a squared plus b squared. C squared equals 4 squared plus 6 squared. You're all good at Pythagorean Theorem now. C squared equals 52. And it becomes c equals the root of 52. But wait, I just gave you fair warning. We're going to have to simplify radicals. And I would ask you, is that 52, that root 52, simplifiable? Does it contain a factor that is a perfect square? And it absolutely does, because 52 is divisible by 4. So c is equal to root 4, root 13. 52 is a product of 4 and 13. But we can solve the square root of 4, and we're going to get c equals 2 root 13. Really, these solving exact trig ratios are just an exercise in can you simplify. So we're going to fill in this hypotenuse right now. It is 2 root 13, and now it's time to solve the three trig ratios. We're going to move this up so we can get some more space here, and we're going to do the first one, sine. Our sine of theta, which is the opposite side divided by the hypotenuse. So our sine of theta is going to equal the opposite side, 4, divided by the hypotenuse side, the 2 root 13. And I will ask you, is this ratio, because we got it right now, that is the sine ratio, but it's not the simplified exact version of the sine ratio. We got to keep going. We got to use all of our little math skills. The first thing we should see is that 4 over 2 is reducible. So we could write this as, we do 4 divided by 2, 2 over root 13. However, you should also recognize that we cannot leave a radical in the denominator. To get rid of that root 13 on the bottom, we are going to have to multiply both the top and the bottom by root 13, which means that our final answer is going to be sine of theta is equal to 2 root 13 over 13. Box our answer. We got the first one, and that can't be simplified any further. 2 over 13 doesn't reduce, root 13 doesn't reduce. This one is now complete. Marvelous. Let's go ahead and do our cos. Our cos of theta is going to equal the adjacent side divided by the hypotenuse, which is going to equal, our adjacent side is 6 over 2 root 13. Same as last time, this is going to be reducible with that 6 over 2. This is going to equal a 3 over root 13. But we just learned how to deal with that root 13 in the denominator. We multiply both the top and the bottom by root 13. It's going to leave us with a final trig ratio of cos of theta equals 3 root 13 over 13. Box our answer. That can't be simplified any further. 3 over 13 doesn't reduce. Square root of 13 doesn't reduce. Tan is cute. Tan is cute, and I'm just going to move this over a little bit, and we're going to do tan in the space that we have left, because tan of theta is equal to the opposite over the adjacent, and after all that hard work, tan of theta is going to just feel delightful. Tan of theta is equal to our opposite side, 4, over our adjacent side, 6, and I would ask you all, is this reducible? 4 over 6 is in fact reducible, and we're left with tan of theta equals 2/3. Thanks, tan, for being nice on us so that we could finish this problem. And that, everyone, is an example of how we can solve exact trig ratios. Remember, the most complicated part of this is dealing with those radicals on the hypotenuse, and as long as you remember to check to see if your radicals are simplified, and to get rid of any radicals that you have in the denominator, you should be able to solve these no problem at all. Thank you very much for watching, and I'll look forward to seeing you next time.